Thanks, James, for the news there. So good morning, everybody else. We've got an excellent session just coming up for you. So we've got Rody doing a protocol comparison, even going to show you some interesting stuff with adding GPU to the mix. So take it away, Rody.
Okay, thank you, Jim. Welcome, everybody, at my session. My name is Rody Kossen. I'm a consultant at a Dutch IT club. I'm a Citrix CTP and also very interested in GPU. So I'm going to show you some stuff today. So I'm also an NVIDIA NGCA and part of the Team RG community club. You can reach out to me via Twitter or on my website. All right, enough about me. What to expect today? So we will talk about user experience because, in my opinion, it's the most important part of your workspace. So let's talk first about some basics behind the different remoting protocols used to enhance the user experience, just to understand which decisions you can take and why they change the user experience. And I will show you some different encoders, which will be focused on Citrix, of course, today. Then we will go through how to test the different encoders, and I will show you some real-life scenarios as well, and some lessons learned, of course. All right. So first, some key takeaways. As I said, user experience is key, and take time to invest it and to enhance it. And you need to have basic knowledge of the protocols so you can make the right decisions. And of course, testing your environment with your own applications and your network heuristics. So I will show some tests later on, but don't forget they are just tests, and they won't directly fit into your environment. All right, let's start with some basics. I don't know if somebody already has seen a session from me earlier, but if we talk about remoting protocols, there are so many different terms like H264 or color gamut or lossless, lossy, YUV, but what do they all mean and what's the impact on the user experience? So first thing I want to talk about is colors, because colors are something most of us can see, and they are so normal. But are they still normal in a virtualized environment or in a computer environment or in a digital world? So we can only see 10 million colors. So keep that 10 million in mind, because I will come back to that later on. But we see only 10 million colors. And there are some insects or birds like pigeons, which are quite stupid, but they see more than us. They can see 10 billion colors. So they can also see the ultraviolet spectrum and the infrared spectrum, which is pretty cool because imagine how their world looks like, or what they see if they look at the screen. But color perception is very relative. So here you have a checkerboard with the A and B blocks. And do you think the color of A and B are the same? They are. Funny, right? Our brain really tricks us that there's a difference between A and B. And that's due to the shadow which is casted over B. That's why our brain thinks that there's a difference, and also due to the checkerboard. So if you don't believe me, create a screenshot of it, take a color picker and just check if they are the same color, or create or pick a sheet of paper, make a small hole in it, put it over the screen, and just look through the hole. You will see if you place it on the A box or on the B box that you will see the same color if you remove the rest of the environment. So I find it pretty funny that we're really tricked by our brain in terms of colors. And there are other things, especially in the digital world, you need to look at. So as I said earlier, we can only see roughly 10 million colors, which should be enough in a 8-bit world, because 8 bits in computer color bit depth means that you have 16 million colors. So it's more than we can see. But if you look at the right picture, you can see that there's no fine granularity between around the sun. You can really see lines where there is not enough color information to show the different tints of orange, for example, different colors of orange. So that's why you will see more colors in a virtualized or in a computer environment. So we have 10-bit, which is more than 1 billion colors. Most of these colors we can't see, but it gives a more smooth image. And this is also used for color compression. So in a remoting environment, if you lower the color compression, you will notice that you will get the image on the right side instead of the left side. So it's a good thing to keep in mind if you do color compression. So talking about compression, why do we really need it? Why do we need compression of a video stream, or in generally, why do we need compression? Because it's also a valid question, for example, a video that you see on Netflix or a Blu-ray which you put into your Blu-ray drive. So if we look at a full HD resolution, just a single frame, if we save it uncompressed, it almost takes roughly 6 megabytes per single frame. So if you have a 30 frames per second stream or movie, it's already 180 megabytes per second. I don't think that somebody has a connection at home which can do 180 megabytes per second. And if we go further and we pick 4K resolution, it's 24 megabyte per frame, which means for a 30 frames per second movie, it's roughly 700 megabytes per second. And if we go up to 60 frames per second to get even a more smoother image, it's more than a gigabyte per second. That's insane. So that's why we have different options in place to compress the image. So there are a few different compression mechanisms. So first of all, there's lossy compression. And you can see it, I hope that it's visible via Zoom, that on the left image of the bird, you can see there's some form of compression, but on the right side, you can see that the image is more blurred and there's information loss. So if you look at the feathers of the bird itself, you can see it's more one thing than you can see on the left side. That's because we use lossy compression here, and it's irreversible. So we literally remove information of the image, but it's used to reduce data size, and you can reduce it quite heavily. So a few examples for audio, for example, MP3, for still images, JPEG compression, or for video images or video streams, H.264, which is a very common encoder, which is also used by remoting protocols, which I will show you later on. But it's also used for Blu-ray images or DVDs. So it's quite commonly used. And on the other hand, we also have lossless compression, which is compression, and it's done by taking out duplicate data, so deduplication and other forms of compression, and it's reversible. And that's a good thing, because lossless compression is also used in zip files, for example. So zip files need to be reversible, because otherwise, if you zip something, you can't unzip it later on. But another form of lossless compression is also PNG, which is used for images. Or if you look at audio, so you have FLAC for instead of MP3, and on Blu-rays you will also find Dolby True HD, for example, which is also a form of lossless compression. So there is compression, but it's lossless. And another term that Citrix invented is visually lossless, which is still irreversible, but they say, okay, the difference can't be seen by the human eye. So keep in mind that it's a form between lossy and lossless. And as I said, the video streams really need a form of compression. And one of the most common ones used, I think in 90% of the times, H.264 will be used. So even I think Netflix still uses it, YouTube if you use Internet Explorer, on Blu-rays, as I said, and also the different encoding protocols of the different vendors out there use H.264 because most of the endpoints can also decode it. But let's look at the tricks or the magic of this encoding type. So I did a funny size comparison. So I took a screenshot, which you will see at the right side of the screen, of a tech website that I always read in the Netherlands, a Dutch website, tweakers.net. So I took a screenshot of it in full HD resolution and saved it as a PNG file. So that's lossless compression. And it's around almost 900 kilobytes in size. I did the same with JPEG compression, and it's roughly about 500 kilobytes, 450, 500 kilobytes in size. And I also took a screen recording of it. So 5 seconds with 30 frames per second, which means if you compare it to a still image, you have 150 screenshots, so to say. And it's only 400 kilobytes in size. So you can see that a video codec really can reduce the amount of data used. So it's a big difference with just a still image. It's even smaller just than a JPEG file. But the compression comes at a cost. Because H.264 uses Chroma Subsampling. And Chroma Subsampling reduces the amount of color information in the image. And it's based on the idea that our eyes are more sensitive for luminance or brightness than for color. So the small differences in color will not be noticed by our eyes, but if you have difference in brightness, that's something we can definitely see. So with Chroma Subsampling, we can reduce the color information, and it can reduce the file size up to 50%. Which is a great thing if you want to compress your image. And they use YUV. So the term YUV, I told earlier, is also used in combination with Chroma Subsampling. So I don't know if people know RGB, so red, green, blue, which was an old way of giving every pixel color information. So you can create every color from the RGB perspective. So a bit of red, a bit of green, and a bit of blue, or all the colors together, create white, no colors, create black. And so with all those different combinations, you can create all the different colors. But that color system doesn't have a different component for luminance. So that's why they created a new coloring information system called YUV or YCBCR, which is also used in the analog world. But in the digital world, we use YUV, where the Y is the luminance part and the U and the V are the color parts. And the good thing about that is that we can play around with it and remove color information without removing the luma or the brightness of the colors. So here you have an example of the different Chroma subsampling options, and maybe you have seen them before. So if you don't do Chroma Subsampling, it's YUV 444. And it's in the top left quadrant. So you have the Luma part of the pixels. You have the Chroma part, so the U and the V part. And if you combine that, you have the final pixel. So you have a block of 4 by 2 pixels here, so 8 in total. And with 444, we take all the Luma, take all the color, and the final pixel will be completely with all the color information. But to compress the image more, and as I said, our eyes are not so sensitive for the Chroma part, we can reduce it. So all Blu-rays, all YouTube videos are rendered or encoded with 420 Chroma subsampling. And that's the bottom right quadrant. So we still take all the Luma or the brightness, but we only take 2 of the 8 pieces of color information. And the final image is really different than the 444 image. But if you look at the complete resolution, so if at the complete image, this is all small pixel level image information or color information. So if you look at a complete picture, you won't notice the difference, especially in a moving image like a video stream. But there's a downside, and the downside is really with still images and also with high contrast images. So if this doesn't or if this isn't really visible in the Zoom session, please go to Google, Google for YUV 444 versus 420, and you will see the difference on your screen. So on the right side, you can see that we have a red, for example, red background with blue text, and the text is very thin. So there's a sharp contrast between the bright red and the dark blue. And if we look at the left side, you can see that with 420, the colors tend to blur into each other. As you've seen on the previous slide, there's less color information in the 420 Chroma subsampling option. So the red and the blue are blending into each other, and that means that there's also less difference between those two, and that's why the text with 420 is getting blurry. And this is also seen in situations where you have small lines, for example, with 2D CAD using AutoCAD. Most of the CAD engineers also use bright colors on a dark background, and on the left side you can see that 420 is struggling to make a sharp image of it, just because we removed all the color information. And all those things are used by encoders and can also be seen in the different remoting protocols. And there's so much more to tell. So I wrote a quite extensive blog post about it. Please take a cup of coffee with you if you start reading it, because it's tough, but yeah, there's so much more to tell about those basics. So enough of the basics, let's go to the different encoders. And you will directly recognize the different options for the Citrix encoders in terms of the basics. So Citrix CFAT 2003 is the latest version currently, and they have different encoding options like ThinWire, which use a combination of JPEG and PNG. So a lossy and a lossless compression. They can do adaptive display or actively changing regions, which is a combination between a video codec, H.264 or H.265, and ThinWire. I will show you a bit more later on. They also have the option for build to lossless, which will use H.264 for the moving image part. So if something moves on the screen, or if you zoom in and zoom out, they will use H.264 compression. And once you stop moving your screen or mouse, they will build it up with PNG, lossless. And they enhanced it greatly in the latest releases. There's also a Citrix blog post about it. So that's also a very nice encoding option. And the other options are H264, or it's called for the entire screen, which we can use YUV 420, which will do color compression. H264 for the entire screen, YUV 444, so without color compression. And you can also use the newer codec H265, which is a successor of H264, to do even more compression on the video stream, and it can reduce your bandwidth by 40 to 60%, depending on your scenario. But it comes at a cost of compression, compute power needed. So you can do only H265 if you have a GPU in your virtual machine. And the last codec that Citrix still has is lossless compression. So they do only deduplication, but no image compression or quality compression. And if you add a GPU to the mix, so for example, if you add an NVIDIA vGPU to the mix, you can see that you can offload many of those encoders to the GPU, which will reduce the CPU load, which I will show you later on in the session. All right, so now we have talked about the different differences encoders in different encoders. Let's go to some tests. But first of all, how to test. As I said in the beginning, it's good to test with your own applications, but sometimes you just want to do a repeatable test. So first of all, you can do a benchmark on your environment just to see how fast it is. How many frames per second can I run on my VM? just to get an idea of the raw performance of your environment. But it's not really, it's not really a user test or a good test to see what the user experience is like. So it's better to test with tools like Login VSI to do a density test, or use Rex Analytics, which I use mostly to do a repeatable test where you can also show the user experience. And the good part of those tests is it's also scalable. So you can add multiple virtual users. So you can have noisy neighbors. Because if you test on a server with just one user, that user will get the whole raw computing power of that server. But what happens if you add noisy neighbors, other people that also put load on the system? You also want to check what that means for the user experience. So user experience can be great if you have one user on your system, but what if you calculated it for 64 users? You also want to check what the user experience is for that one user if there are 63 other users putting load on the system as well. So that can be done with those testing tools. And the last thing, which is also great to do further on in your project, is a Pepsi Coca-Cola test, right? So give a user two options and don't tell them the differences between those options. So just give them two laptops, for example, already started sessions on it, and just let them try it out and ask them about their opinion and what they think the differences are between those two. And if they like the cheapest option, then you're good to go. And if they like the other option, then you have some work to do. One useful thing for testing the different encoding options is RD Analyzer. I'm co-developer of this tool. It's a community tool created by a few people. And it supports the different encoding or the different remoting solutions like Citrix, of course, VMware Horizon, Microsoft RDP, Windows Virtual Desktop, and hopefully in the future we will add more remoting protocols from other vendors as well. And you can live monitor the remoting protocols. On the right side, you can see a screenshot of the tool. So you can see how many frames per second are sent to the user, what's the bandwidth used by the encoder, what's my network latency or my complete round trip time, how much GPU is being used by the encoder. And the cool thing is, if you use Citrix or VMware, you can also, on demand, in your session, change the encoding options. So you can switch between the different encoding options. So for the entire screen, or go back to thin wire, you can change the quality, turn on hardware encoding or turn it off, and you can do all those things live, and you can test the differences and write down the best solution for yourself and configure that later in group policies or in the Citrix Studio. So it's a quicker way to test all the different options. So I test everything in my lab. I have a lab with a NVIDIA GPU, and you can see it's modified to keep it cool, because a Tesla T4 is normally in a surface chassis with good cooling. So I have a 3D printed part which I need to put on the T4 with a 12 centimeter fan on it, just to keep it cool. But I can run all the different workloads on it. So it's good to have a good testing solution. But still, don't forget to test with your applications and your network behavior, because your bandwidth, latency, or packet loss can change the user experience as well. And test with your endpoints. All right, so let's go into some real life scenarios. Let's show some stuff. So the first scenario I want to show you guys is the CAD worker, so a heavy 3D or 2D worker, which relies on applications like AutoCAD, or 3D applications like SolidWorks or Siemens NX. They require a video card in the VM to offload or to utilize the different CAD tools. So we add a vGPU like a T4 to the mix with a 2 GB or 4 GB frame buffer, depending on your endpoint resolution, with a Quadro license on it to license it for CAD workloads. You can have 2 or 4 vCPU, depending on the application. But also look at the speed of your CPU. So always use a 3 gigahertz or higher clock speed for those workloads, because they most of the times are still single-threaded and rely on clock speed. And with CFET, we can use NV encoding to offload the encoding of H.264 also to the graphics card we added to the mix. All right, so let's start the first video. So in this video, you will see the CFET workload with a YUV444 encoding. And I just took a 3D CAD model with the Lego Designer, because it's a simple tool to use, and I can repeat the simulation multiple times. So I hope you can see that we have a very smooth frame rate here. So just 30 frames per second, the maximum I put in. And we don't have any color compression. So if this doesn't work correctly on this session, I will share a YouTube playlist later on Twitter, where you can see the different videos as well. All right, let's continue. So, yeah, all right. So for this situation, I use the video codec for the entire screen, which uses H.264. I set the image quality to always lossless, enabled the hardware encoding, and enabled also the option visually lossless, which will enable YUV444, and that can also be offloaded with hardware encoding to the NVENC engine in the GPU. So we have no color compression for this image, which is great for this situation, especially with 2D CAD, as I explained earlier. But this only works on Windows endpoints. That's something you have to keep in mind. But okay, if you have a Windows endpoint, everything is fine, right? So we're very happy. We have happy end users. They have good image quality. But then COVID-19 came around. And now suddenly that worker is working from home with the same setup, but only with a 4 megabit connection because they have ADSL at home. So let's look at the next video how that will work if you only have a 4 megabit connection. So let's switch to the video, the second one. All right. And no, it's not the session that's the issue here, but you really see 3 frames per second. Because the settings we choose requires roughly 50 to 80 megabit per second for this situation, for this image which you see here. So we have a sad user. They are not happy because they can't work with just 3 frames per second. So how do we optimize the user experience? So what if we change it to build to lossless? So let's start the next video where you can see the difference between the YUV444 on the left side. So the top left quadrant is the video of YUV444 and the right top quadrant is build to lossless. And we have the same 4 megabit connection here, but we only changed the encoder settings. And on the down half of the down half of the screen, you can see the different metrics, so CPU usage and also the GPU usage and the encoding usage. So we still can use the NVIDIA encoder to encode the video stream on the GPU. But you will see that there's a big difference. So on the right side, you can see a smooth video stream, 30 frames per second, where you can see color compression, where you can see image compression. But as we use build to lossless, once we stop moving the image, it will build up with PNG. So we have a lossless image. And on the left side, you can see that the encoder is still struggling to get the frames per second to the line. So build to lossless is a really good combination for this scenario. So the optimal settings for this situation is to use still the video codec compression for the entire screen, but we set the image quality not to always lossless, but to build to lossless. And we still enable hardware encoding, and we still enable visually lossless. And we also enable Optimise for 3D workloads. That's needed to have, for the entire screen, use H264 on the GPU in this situation. And why did I enable visually lossless? So with a Windows endpoint, you can do YUV444. So build to lossless can still utilize YUV444 for the moving image. So H264 YUV444 for the moving image, and once the image is a still image, it will be built up with PNG, but you will still have a visually lossless image. But it can do still compression to lower the bandwidth need. And if you don't have a Windows endpoint, for example, a Linux or a Mac OS, it will do a fallback to 420. So this is a very good mix. So the best image quality on Windows and the next best option for the other platforms. And make sure to also enable EDT and EDT MTU size detection for remoting scenarios. If you don't know what those options are, just Google them or look up the Citrix docs. I don't have the time in this session to tell about those options, but look them up and enable them, please. So the last scenario I have for today is a very common scenario, so the office worker, which uses applications like Microsoft Office. But I see more and more usage of videos as well for those scenarios, for this scenario as well. So YouTube, for just looking up a quick video or an instruction video on the internal SharePoint website or something like that. So it's a mix nowadays. We can do that with VDI. So we have a 2 vCPU scenario with 6 GB RAM for Windows 10 VM. If we add a vGPU to the mix, you will see a 1 GB or 2 GB profile with the B profile from NVIDIA, the basic profile for the knowledge worker. Or we can do it also with Citrix Virtual Apps, so an SPC scenario, where we can have multiple users on one VM. And if we add a vGPU to it, so an NVIDIA vGPU, we can still use the same Tesla card, the Tesla T4, but we add a special profile for the virtual app, so the A profile, to the mix. So talking about a GPU here, do we really need a GPU for moving images? So let's look at the differences between a CPU and GPU scenario here. So let's start a video. All right, so in the top left screen, you will see a CPU only scenario, and on the top right screen, you will see a GPU scenario. And when I did this test, I was really impressed with the quality and the smoothness of the left scenario. So only 2 vCPU. So Citrix really did a great job to run this on the CPU. But you can see on the top left quadrant, the CPU usage, that it's going through the roof. So we use 100% CPU usage in this scenario. So you can't run any other application next to the YouTube video, where you, in the GPU scenario, so the green part, you can see we only use around 30% CPU usage. So in terms of sizing, I think you really need a GPU for this, because if all users are using videos, you really overcommit your CPU. All right. So let's look at the difference then between using a video codec and a JPEG, or the thin wire encoding for the moving images. So do you really need to use H.264 for the video stream? So let's look at the next video then. So on the top left, you can see the thin wire encoded video, and on the right side, you can see the H.264 encoded video stream. It's backed up by a GPU to run this scenario, but we can't use the GPU to offload thin wire. So I use the same 3D model again here, and it's loading currently. All right, it's still loading, and once it will run, you can see almost the same behavior as we saw earlier on with the 4 megabit example. So the JPEG encoding is really struggling to keep a smooth frame rate. It's stuttering. It's getting 10 to 15 frames per second, and it's using more bandwidth even than the H.264 stream. So it's really important to use a H.264 stream when using videos. All right, let's move on. As I told earlier, the H.264 uses BioV 420 by default. And that does compression. And compression with 420 was bad with text. So what if you use Microsoft Office with the H.264 option? You can clearly see that the text is blurry. It's not sharp. This is really hard to read. So if you use Microsoft Word or Excel, for example, and you use a H.264 based encoder, like for the entire screen, the user is not happy. So we have choices now. So on the left side, we have the user that uses that once you have H264 when they have a video stream, and on the right side, when they switch back to Microsoft Office, they want to have thin wire, JPEG or PNG encoding. So luckily, there's 4 actively changing regions. So it can detect what's on the screen. And here you can see that it uses, for the green part, which is a video stream, H264, and uses thin wire for the text. So it's a combination. It detects what's on the screen and changes the encoder for that part, which is really good for this scenario. So if you ask me, for the office worker, the optimal setting is 4 active changing regions with the image quality set to high. And you can use hardware encoding if you have a GPU, which will offload the H264 stream to the NVIDIA encoding option on the GPU chip. And it's supported on all endpoints. So what did we learn? As you have seen during the different tests, you need to optimize the encoder for different workloads. So a CAD workload is really different than an office workload. And it also depends on the network conditions you have. Because as you have seen, a 4 megabit connection instead of a LAN scenario has a high impact on the user experience. And even if you add packet loss to the mix, that will even further put the user experience down the drain if you don't optimize it correctly. And try to keep up with the latest releases and the release cadence of Citrix. So please upgrade your environment quite often to get the last and the best features that Citrix releases, like EDT, build to lossless enhancements, and other optimizations. You will get better user experience for free. And last but not least, just try everything out, make mistakes and learn, because as you can see on the right side image, children also try, they make mistakes and they learn from it. So why are we scared to make mistakes? So the key takeaways I want to give you from this session is that user experience is really key. So invest time to enhance it. And you need basic knowledge of the different protocols to make the right decisions. Otherwise, you will end up maybe even with worse user experience than you had out of the box. And test with your environment, your applications, and your network heuristics. So that's the end of my presentation. I hope you learned something for it. If you have questions, you can always reach out to me. I don't know if we have some questions in the Q&A.
Rody, we don't actually have any questions for you, I'm afraid, at the moment.
Okay, no problem.
I'm sure people can catch up with you on Twitter if they want to get additional. The recording of this and the slides will be available on our community site as well. So all the collateral is available. So Rody, thank you so much for coming along and sharing your knowledge with us. I think we'll move over to the next session now.
Thank you.